Gasoline at 60 degrees Fahrenheit flows through a 1-inch pipe with a velocity of 0.1 foot per second. What is the Darcy friction factor and the head loss for 50 feet of pipe? So looking at this problem, the first thing that we have to do is we have to calculate out whether or not we have laminar flow or turbulent flow. And we better hope that this is laminar flow since we don't know how to handle turbulent flow yet. Let's look in the book and find out what gasoline at 60 degrees Fahrenheit is. We need some of its properties. So if we go and we look, 60 degrees Fahrenheit gas has a kinematic viscosity of 4.9 times 10 to the negative 6 foot squared per second. So from there we can calculate out Reynolds number. Reynolds number based on diameter is the velocity diameter divided by the kinematic viscosity. Our velocity is given to us as 0.1 feet per second, and we have a 1-inch pipe. So 1 inch, we need to convert that to feet so everything's unitless. So we have 1 foot divided by 12 inches, and then we're going to divide that by our kinematic viscosity, 4.9 times 10 to the negative 6 foot squared per second. So if we take a look at that, I've got seconds, inches, foot squared here, all cancels out, unitless numbered, good to go. 1700 is my Reynolds number. Thankfully, I know that means this is laminar flow. And I say thankfully because the only way that I can handle friction factor right now is for laminar flow. So the friction factor of a laminar flow is going to be 64 divided by our Reynolds number. So 64 divided by 1700, and that gives us a friction factor of 0.0376. Now that I have my friction factor, I can go to my Darcy-Weisbach equation. So H of F is FL over D V squared over 2G. Darcy friction factor is 0.0376. Length of my pipe is 50 feet. My diameter is 1 inch. Once again, I need to convert this to make sure the units work out correctly. So that's 1 foot over 12 inches. Now V squared, we've got our V calculated as 0.1 feet per second squared divided by 2G, so that's 2 times 32.2 feet per second squared. So as we look at this, HF should be a unit of linear measurement because it's our head measurement. So L over D, all the units cancel out. I've got feet squared, second squared up here, feet per second squared down here. I'm going to end up with a unit of feet, which is great, which is what I expect. And my answer would be 3.5 times 10 to the negative 3 feet. So this is how much energy I'm losing over that 50 feet of pipe.